Hey guys, this video is about the scientific method. Okay, the scientific method has a few different steps that we technically follow in order to provide a solution to a scientific problem. I know you guys have often learned the scientific method in the past, but with chemistry, it's really good to follow the scientific method and always kind of keep it in the corner of your mind as you're working with experimentation, just in case you run across a little bit of a problem. Okay? Now, the scientific method is a logical, systematic approach to the solution of a scientific problem. It consists of 4 steps. Okay? The first step is observation. All right? Observation is understanding something is not quite right. All right? So, it is the use of your senses to obtain information directly. You notice something is not working properly. Okay, now with this, you must be communicating with other lab partners or other scientists in order to kind of come up with a good scenario. Okay, now, where do you extract your data from observation? There's 2 types of data. One is qualitative and one is quantitative. Okay, qualitative is a descriptive form like size, color, shape, etc. Quantitative is a numerical number like the quantity, the amount of mass, the volume, etc. Okay, the second step is the hypothesis step. Is a proposed explanation for an observation. This is where your intuition kicks in to help predict the solution to the problem. This is where you're going to formulate a method to fix what you have observed. Okay, so we're going to write a testable statement at this point. Okay, so the hypothesis is going to include a testable statement that later on you're going to perform in the next step, which is step 3, the experiment. Is a procedure that is used to test a hypothesis. It provides data to support or refute a hypothesis. Okay. Now the data, there's 2 parts to it. One's going to be an independent variable, which is a variable that you change. Also will be plotted on an x-axis. For an example, if you're going to increase the heat. Okay. So as you increase the heat of something, what happens to the volume? Well, we all know when you heat things up, there's a volume change. Okay. Now the other variable is a dependent variable. It's a variable that is unchanged and observed. Depends on the independent variable. Okay. And that would be like the volume. The volume is changing. So that would be your dependent variable based on the increase in the heat. Okay. This variable depends on the other variable. That's why it's called the dependent. Okay. Now, very important about the experiment. If an experiment proves your hypothesis false, come up with a second hypothesis. Okay, so let's talk about WD-40. Okay, WD-40 has a number 40 next to it. What does that mean? That means it actually went through 40 series of tests to come up with the final product. W stands for water, D stands for displacement. So it's a water displacement formula number 40. So they had to go through 40 different hypotheses to finally get the experiment to work correctly. Okay, so if your experiment does not work right, you have to go back and create a new hypothesis. So luckily, if your hypothesis is correct, you only have to do one experiment. If it doesn't work, then you have to go back and create another hypothesis. If that doesn't work, you have to go back and create a third one, so on, so forth, until you get it right. Now, the 4th step is a theory. Okay, a theory is a well-tested explanation for a broad set of observations. You note why each experiment if more than one gave certain results. Construct models. Okay, so here's a general flow chart. Observing, formulating hypothesis, testing, and then you can go back to formulating hypothesis if the data does not support the hypothesis. Okay, the last part of the scientific method is the scientific law. Now, what is a scientific law? Okay. Let's talk about this. So for the experiments that can be proven time and time again with the same repeated results, we can further classify them as formulas or scientific laws. Okay, so if you notice something happening time and time again, you can actually create a formula or a scientific law can be established. So, scientific law is a statement that summarizes the results of many observations and experiments. This is done a lot for chemistry and physics. Okay, like temperature. If you increase the temperature of a piece of metal, that metal will expand. If you cool that metal down, it'll contract. Okay, so there's an expansion and contraction every time you heat it up, then cool it. Okay, so there's formulas for that. Now, here's a formula for Isaac Newton's formula. So the apple fell from the tree. He created the formula Fg equals G times M1 times M2 over R squared. Okay, and he figured this out. Mass of the one object to the other object, radius squared, and that's the force of the gravitational pull. And he noticed this could be applied to the apple, and every time it falls, this is the force of gravity. So all formulas. Density equals mass over volume. I know you guys heard that one before. D equals M over V. Okay, it's a ratio of mass to volume. Okay, so you have density of different substances will always be the same. Oils are like 0.92 every time. Okay, very close to ice. Gasoline can be at 0.5. It's always going to be 0.5. You need to do is, what are the 4 steps of the scientific method? You need to know those 4 steps and be familiar with all those parts to them. Okay, so going further, make sure you understand the 4 steps to the scientific method. Observation, hypothesis, experiment, and theory. Okay, you want to be familiar with them and know them. Okay, also the scientific law. I just gave you many examples, but just know the main portions of what we discussed today. All right.